In this video, we're going to talk about trigonometric equations. This is the second part of the two videos, and so this will be part 2, where we look at solving equations with both half angle and multiple angles. So the strategies for solving are just about the same. We are going to bring in some of the identities that we have, so we'll kind of show you how those apply. Anytime we're dealing with a half angle or a double angle, it is important to kind of know that if you're asked for x to be in a certain interval, the half angle is, if I divide everything by 2, right, it's going to give me the interval where the half angle should be. So we can kind of look for solutions by referencing that. Okay, so we're just going to do a bunch of examples together to kind of give you an idea of what these could look like. The first one here says solve the equation, find exact solutions in the interval from 0 to 2 pi. Okay, so we have the sine of x over 2 is equal to the square root of 2 minus the sine of x over 2. We can get common terms together. These are both the same. So if I add sine of x over 2 over to the left side, that's going to give me 2 times the sine of x over 2. And then I can divide this 2 over to the other side. I'm going to put parentheses here. Okay, and that starts to look familiar, right? So I know of some angles where the value is square root of 2 over 2. Okay, so if I'm looking for x values between 0 and 2 pi, remember I'm looking for half angle values between 0 and pi. I think that's going to work out perfectly for us. So let me bring in our unit circle. So the value of the sine is square root of 2 over 2 at 45 degrees, or pi over 4. So x over 2, we could say, would be the inverse sine of square root of 2 over 2. And the inverse sine of square root of 2 over 2 actually could have two possible values, right? The sine's going to be positive here in quadrant 1, but also here in quadrant 2. So it would be pi over 4 and what is that? 3 pi over 4. Oops. Okay. So let's set them up separately. Remember, our goal here is to solve for x, so we just really need to multiply both sides by 2. And that's going to divide out with the denominator, so leave us with pi over 2. And same thing over here, cancel out with the denominator, and 3 pi over 2. These are the two angles where the value of the sine is square root of 2 over 2. Let's try another one. This time we're going to solve the equation. We're going to find the exact solutions in the interval from 0 to 2 pi. Okay, so we have sine of x times the cosine of x equals 1/4. We're going to bring in right? If you can, we have these two. Okay, so all the strategies we talked about in the last video, maybe we could factor them so that they were in opposite terms, but that doesn't really work here. So we need an identity. So we would look for an identity where sine and cosine are multiplied together. One of those identities is the double angle for the sine. Okay, so this is almost the same, but we're missing the 2. We can get that 2 if we multiply this 4 over to the other side. Okay, so if I multiply both sides by 4, I'm going to have 4 times the sine of x times the cosine of x is equal to 1. If you want to break this up, you could, right? Think of it like 2 times the sine of x times the cosine of x. So now I'm going to make a substitution for this part, and that we know is equal to the sine of 2 times the angle x. So now I want to solve by dividing by 2 on both sides. Okay, since I'm using a double angle, let's go ahead and look for where are the angles going to live, right? We have said that x, this is given in the problem, is going to be between 0 and 2 pi. So if I multiply everything by 2, that means 2x is going to be between 0 and 4 pi. So I want to look at all the angles. 4 pi would be 2 full rotations around the circle that have a sine value of 1/2. So we'll bring in our unit circle. Okay, so the value of the sine is 1/2 when we're talking about a 30-degree angle, or pi over 6. So what we have then is 2x is the inverse sine of 1/2. So one option is pi over 6. Okay, remember we got to go all the way around the circle twice. Second option would be right here before we get to pi. So that would be 5 pi over 6. That would have a positive sine value. Quadrant 3 is going to have a negative sine value. Quadrant 4 is going to have a negative sine value. Then we're back to quadrant 1 in the second go around, right? So 2 pi here would be 12 pi over 6. So this one more than that would be 13 pi over 6. And then if I kept going, this would be 3 pi, that's 18 pi over 6. 1 less would be 17 pi over 6. That's going to give me all of my options between 0 and 4 pi. Okay, so each of these is equal to 2x. Now I really need to divide them all by 2, right? You could set up separate equations if you like. You could do it in your head if you like. Just because I want to be super obvious so it's clear to everyone, I'm going to go ahead and set up an equation for each one. But I definitely think you could probably do this in your head. Okay, now I'm going to divide both sides by 2. Dividing by 2 is the same as multiplying by 1/2. So I'm going to get pi over 12 for this one. I'm going to get 5 pi over 12. You can probably see the pattern here. This is going to give me 13 pi over 12. And 17 pi over 12. Okay, if you wanted to check these, you could always check these in your calculator. Take each one separately. I always recommend going all the way up to the top and plugging them in, and they should work. All right, how about one more? This time we want to solve the equation. Now we want to find all the exact solutions, right? Not just between 0 and 2 pi, but everything. So we're going to talk about how that works. Okay, first let's get started. So we would like to have all the same trig functions here, and because this is the double angle and we have a sine, it makes sense to use the double angle formula for cosine that involves the sine. So let's start with that. And all of these formulas I'm pulling out here are on your formula sheet, right, from the last chapter. So don't get rid of that yet. Keep it by your side. Okay, so now we would like to maybe put this in a form that we could solve. Notice there's a 1 on both sides, so I could subtract, and those 1s are gonna go away, cancel. The next step would be to add this 2 sine squared x to both sides. I know it's really tempting to divide by sine of x here because you see it on both sides, but dividing is going to cause you to lose one of the solutions. So we're going to get 2 possibilities here, and if you divide, you'll lose one of those possibilities. Also, when you divide on both sides, you can only divide by something that's not 0. And since we don't know the angle here, and the sine of some angles are 0, we really can't be guaranteed that we're not dividing by 0, which is really invalid. Okay, so for those reasons, we really do better if we get everything on one side and then try to factor. So let's do that. These both have a sign in common, so instead of dividing, we're going to factor it out. Okay, and then we're going to use that 0 product property, and we're going to set the sine of x equal to 0. And we're going to set 2 sine of x minus 1 equal to 0. And then we would like to, well, this one's already solved, but let's go ahead and solve this one. So if we add the 1 over, and divide by 2, okay, now we want to think about, before we do this actually, let's think about the period for sine, right? The period for the sine function is 2 pi. So that means whatever values we get for our angle here, 2 pi radians later, we're going to have that same sine value, right? And then 2 pi after that, and 2 pi after that. So this is going to factor into us including all of the solutions, right? We want to include all the ones, and so we're going to use a pattern, and we've done that in the past, so hopefully it'll be not too bad. Okay, so this becomes, if you want, sine inverse of 0. So let's pull out our unit circle. So the places where the sine value is 0, let's see, the sine is the y value, so that would be at 0. Let's start with between 0 and 2 pi, okay? and then we'll add on the rest. So from 0 and then add pi. Okay, and then we back to 2 pi, 3 pi, okay, and so forth. All right, so really we're going to have, well, let's think about that again, actually. 0, pi, 2 pi, 3 pi, and so on. So really, any multiple of pi is going to be a solution. All right, so originally I wrote it like this. That's going to be all of the places where we hit the x-axis, right? At 0, then I go a full rotation, I'm back here to 2 pi, a full rotation, 4 pi, etc., right? And here is any integer. Okay, and I could do the same thing for pi. So pi, right, over here on the left, and then I rotate all the way around to 3 pi, again around to 5 pi, right, and I can just keep adding the period over and over again. Again, n is an integer here. All right, I think we could actually condense these. I didn't really think about that. This is a fine answer, but this would also be the same, right? Any multiple of pi is going to have a sign value of 0. So that would work as well. Either of these would be fine. Okay, let's do the same thing for the 1/2. So we have a y value of 1/2 when we're working with 30 degrees, or pi over 6. We've done this one several times, I think, right? So we have pi over 6 on this side, or for a positive sign value, it could be 5 pi over 6. I think that's all, because down here it's going to be negative, and down here it's going to be negative. So this is going to give us pi over 6 and 5 pi over 6. Okay, and the same thing's true, right? Pi over 6, but then I could go a full rotation back to that same spot and have the same sign value. So we could have x equals pi over 6 plus 2 pi n, and x equals 5 pi over 6 plus 2 pi n. I don't really think there's a pattern between these two. You could argue with me on that one, but I don't think that's true. Okay, so I think these are the solution. And then you could either use this for these two, or if you wanted to combine them into one, you could do that. Okay, and this 2 pi n, again, where, let me write it off to the side here, where n is an integer. You may see it written like this. So this means that n is a member of the set of integers that you usually use a z for. So that means I can put any number in there and I would get another solution, and another, right, for any number I put in. All right, well, I hope this kind of added to some of your knowledge about solving these equations. This is, again, one of those things that we will practice and practice and practice so we can get it down and get a good feel for it. I feel like it's really important, especially if you're going on to any other classes like I'm thinking physics or statics or things like that. This is going to come up. So good luck, and we'll see you in the next video.